unmanned systems. So I've pretty much seen everything from when we had the pioneers field it through the entire development cycle. And I was a little bit annoyed at Mike because he basically hit on every point that I wanted to make as far as where we're going in the future. Because we kind of started off with the Wild Wild West. We had a few of these things kind of hanging around. Nobody knew what to do with them. Nobody really knew how to take advantage of them. And now the commercial market is just going to put us in the dust. And, you know, from the Department of Defense standpoint, what I keep on preaching, if you've ever been in a meeting with me, is if we don't get on board what's happening in the commercial world, you know, we're going to be left behind, and we're not going to have any influence, and we're not going to be able to leverage what's happening in the commercial world. So that's kind of one lesson that I think that we have all in the Department of Defense have yet to learn, that we are no longer in charge. We basically have already passed the baton, whether we know it or not, and we need to get on board. The other comment about the iPhones, that's exactly the example that I use very frequently. You know, that you got to start looking about these vehicles as simply platforms like an Android or something like that, and it's really the money is going to be in the applications, and that's the beauty of all this, because that means that small companies, innovative companies can come in and really really take control of the marketplace. That's going to drive down costs. It's going to drive up capability. And so if you want to kind of predict what the future is going to bring, you know, somebody told me a long time ago, we solved the mystery of flight quite a while ago. So you're not going to, so air vehicles are, you know, you'll have, you know, it'll boil down to a few players who are really producing these things, just like you do with your electronics, you know, some companies that can produce them economically and high quality, but the real competition is going to be in those applications that are brought on board. And the only other passing thought I have, passing remark I have is that when we look at these things, we have to take a look at the strengths that these unmanned systems bring compared to instance, manned platforms. You know, we were debating for a while, for instance, about putting an unmanned, you know, we still are debating about putting unmanned carrier aviation. Frequently people come up to me and say, well, why don't we just unman an F-18? And my answer is, because then you have a dumb F-18. Because, you know, that aircraft is designed to be highly flexible, highly maneuverable, short endurance. That's not really what the forte of an unmanned system are, particularly today, but they have other capabilities. For instance, they're high endurance, or on the other end of the scale, you can get down to the point you don't, because you don't have humans in them, they could do things that you never even would have attempted with a manned aircraft. So there's a whole other marketplace that's available, and that's the capabilities that these unmanned systems are really going to find themselves more in a role for. So when we're thinking about designing these systems, think about the components, the software and sensor components that are going to go in them, and think about the missions that these things really lend themselves well to, and that'll probably give you a little bit of vision for the future as to where we're going with these systems.
Hi, I'm Paul Gellhausen from AVID. My background, I spent 22 years at NASA, both at Ames and at Langley, doing advanced concepts. My biggest accomplishment here at PAX was, I think, in 1983. I was the youngest flight test officer on a airship that NASA ever had, and all the airship testing was done out here in the Bay. The second youngest at the time in 1983 was 75 years old. So I thought that was pretty funny. But anyway, I have spent a month at PAX in the past, but right now, most of my time was spent at NASA. In 2002, I left NASA to start AVID to bring some of the disciplined systems analysis capability that we had on the big airplanes to the UAV world. And so our project was to the beginning of what became the T-Hawk. There were 3 failed attempts at DARPA to do that before they let me get in with that systems analysis. And we I think when we look at what needs to be done, it's starting with the physics and making sure the physics works, and that's what I like to look at as we try to shrink things down. I agree with everything the two gentlemen ahead of me said about trying to make things smaller. In 2003, one of the ducted fans that we were working with was an electric ducted fan. It was a 9-inch diameter. It weighed about 8 pounds, and its endurance was 4 minutes with $1,600 worth of batteries. They were single-use batteries. So it was ridiculous. Today, I have an 8-inch one that we've designed that carries 1 pound of payload. Total gross weight is 3 pounds, and it flies for half an hour. And I think the total cost of the vehicle is, I don't like to quote it, but let's say we're targeting 20K. So bringing it down to that kind of level from where we were only 13 years ago is amazing. And in my DARPA time, or the time I spent talking to the people at DARPA, they were saying, well, they're just going to grow. And I said, no, because I threw my phone on the table and said, these don't grow. So they're right. We're going to keep making them smaller. The things that we're looking at are these infrastructure things, because the ducted fan is very safe. I can bump into things; it doesn't hurt. People keep talking about doing ag things. We can do ag things because I can land it in the back of your pickup. Those kinds of things, I think, are going to be tasks that are going to be out there. So look forward to the rest of the panel.
So my name is Jacob Meschler, and I'm with the University of Maryland ARC Lab. That's Autonomy, Robotics, and Cognition. I kind of fell into the UAV industry and the unmanned aircraft industry. Like Steve said, I was in the airline industry with maintenance and maintenance planning on big airplanes for about 15 years. And then some people came to me from Proxy Aviation out in Gaithersburg. They had a UAV. They had an optionally piloted vehicle, an aircraft that had been converted, and the feds kept shutting them down. So they were having a lot of problems dealing with the FAA, and that's something that we're pretty good at in the airline industry. We know how to work with the FAA. So I got those guys on track, and we developed a maintenance program and then a flight program for their aircraft. Went from kind of prototype to production was the idea. And then I came into University of Maryland, and at the lab we do a lot of different things. We have right now one of our big projects is a DARPA project. We have some humanoid robots, and we're teaching them how to cook by letting them watch YouTube videos, and so that's going pretty well. But we also have some unmanned aircraft and nice an indoor test space, and then we're going to move outdoors as soon as we can. And so we're hoping to take some of that vision processing and some of the systems engineering that we're focusing on and put those together so that we can have collaboration between the unmanned aircraft and the humanoids and the ground robots and all the different things that we have. And I guess for the people working on UAS right now, some of the things I've come across, I think, modularity. It's just like Steve said, writing apps is going to be the really useful and the huge market, the writing applications for UAVs. But right now they're not that modular. You can buy an open source autopilot, or you can buy an open source, even an open source airframe. But there's a whole bunch of different people making different open source things. They don't really work together very well. And so, how do you define modularity? I mean, how we have to decide the Android and iOS are really have done a great job of deciding what modularity is. They get their API out there. Everybody can program for them. It works great. But the challenge with UAS is going to be there's a lot more physics because you have weight restrictions and voltage requirements for your modular parts that you want to put on there. Maybe you have a different sensor that's going to work with your UAV. So the key to that, I think, is modeling and simulation as much as possible. Just try to have nice models of everything so that you can give it to all of your developers and let them test it out. Open source models. We have a little bit of that already with robot operating system that we use in the lab, and we're developing new models for our UAS that allow people to write software and even test out one piece of hardware, using their own simulation without having to buy the UAV or bring it into the lab. So, thanks.
I've been sitting all day, so I'm going to take a chance to stand. Hi, I'm Tony Mulligan. In the mid-'80s, I got my degree in mechanical engineering, and my senior project was a ceramic motor, because as a kid, I was shooting to get the world record for how long a model airplane could stay up in the air with 1 ounce of kerosene. And so I worked at a materials company, and I grew up in a family of very avid model enthusiasts, and we competed all over. But I did actually build this working ceramic motor, and I decided I was going to be a materials guy. And I started a company. 12, 13 years later, the company got pretty big. We were doing a lot of cool projects. The only unmanned system that we got to do in that time was we got to build a propulsion system for NASA called Shooting Star, which was a solar propulsion system that would operate ceramics that went up to 7,000 Fahrenheit. So that was our specialty then, and robotics for making those things. And then in early 2000, we decided we wanted to take our materials technology and our rapid prototyping technology and build airplanes. And Mike was a great sponsor. We got to build so many different kinds of platforms and do a lot of artificial intelligence. To give you an idea, just 2 years later, we were able to do a demo for the Secretary of Navy where we had 3 planes following a convoy autonomously in southern Arizona that he could control from NRL. And then just a month later, we did the same demo for the Armed Services Committee with a cell phone. So we could run everything, and cell phones were pretty crude back then. And it seemed like, to us at the time, the biggest technology jump was getting the cell phone picture to show up on a big screen TV so the members could see it. And but it was definitely, we got to do a lot of exploring. That was a pretty cool project. Another cool project, design project, was I remember sitting in the Admiral's office with Mike, and like, what are we going to do next? And we said, let's build a little plane that fits in a sonobuoy tube. And I thought, but I said, before I say this, you're not going to throw me out of the office. And but Mike and the Admiral loved it, and that was a cool project. It's still going. It's morphed into other things, but I wanted to bring it up because what I learned in that project was the time and expense it takes to get something NAVAIR certified. And by no means am I saying that's not justified, but it's a huge Herculean effort. And a few years later, I sold my business to BAE, and when I was sitting around, we were brainstorming. I actually had a picture, if we had a PowerPoint, I could have shown you, of the behind-the-napkin design that we put together. We said, hey, so much money was spent to certify everything on this little airplane called Coyote to fly out of a P3 sonobuoy tube. With this motor and with these batteries and with this control system, what else could we build with it? You know, what else could we do? Because if we could build something else, the certification process should be really easy and fast and cost effective. And oddly enough, we came up with a little boat that would fit inside of the sonobuoy tube. That when it hit the surface, it would go over 150 miles an hour. And based on what we saw, our thought was like, hey, in any sea state, you know, so we would just go through and we'd pile through the water, or so it's basically a surface skimming 3-sided hydroplane. So it's like a 4-step hydro. And Mike was, again, he stepped up, and I'll say, no, I don't think anybody else thought it would work, but the 3 of us. And but he funded us, and we showed that you could make this 3-sided 4-point hydro work. And when it turns, it spins. It goes. It is the freakiest thing you've ever seen. And but it's to me, it was the ultimate in hydrodynamic, aerodynamic combination. And So we're working on that. We're hoping one day that soon we're going to be launching this thing out of planes, and my NavAir program manager is here, Tony Brescia, hiding somewhere. But the other key when you design something, you're doing something, is long-term sustainability. So for a company, long-term sustainability means money. You got to always have money, and you got to pay your bills. We took what we were doing there and some of the problems, and we put it in a slightly bigger boat for NOAA, so they could take pictures of little sea animals. And so the drivetrain, the electronics, the battery, and especially the 300 amp controller. So I don't know if you start doing work with high surge power, you have these transient spikes and a lot of things that you got to deal with. And we had finally cracked that nut on this little boat. And this one day we were running this little boat in like 20-foot waves, and we realized, like, hey, if we put a life jacket on this boat, we could rescue anybody in the ocean that was in trouble. And so a year later, we were recognized for Invention of the Year from Popular Science. So we built this thing called Emily, so you can look it up on the web page. And now we sell these things all over the world, and for a tsunami response. And you throw it out of a helicopter, because our other idea was terminal velocity. That's our favorite place because we can't go any faster. So if we make it strong enough to hit the water at that, then we're okay. But the design concept was that it's basically really this little UAV without wings, and it has a ceramic pump instead of a aerial propeller, and everything else is the same. So the volume of the components now skyrockets, and the costs plummet, and you always have this warehouse full of a lot of parts. The manufacturing is the same. We use aircraft epoxies, and all of the components are interchangeable. Now, the next thing that happened that was kind of cool was a bunch of planes came back from Iraq, and those all turned into boats. So you have autopilots, you have thermal imagers, you have radios. It's really cheap, and our emphasis is things that you can carry in an airplane, things that are safe in an airplane. So it's a different perspective than what like the guys at AUVSI would have. And even on our rescue boats, the boat was designed so that when it was in its case, it would be the maximum size that you could check on an airplane. And the battery is the maximum number of batteries that you're allowed to carry on an airplane. And then the idea is, okay, that's a first responder can jump on a plane and go anywhere in the world right away. So do you get enough performance? Do you get enough duration? Do you get enough size? Do you get enough flotation? And it turns out you do. And it makes the thing very easy. So our little rescue boat weighs 20 pounds, and you can do like 20 rescues on one battery charge, which means you could rescue up to 40 or 50 people. And it's really significant. It only takes a few minutes to change the battery. Now what we've done is, what we did to waterproof the airplanes when we turned them into boats, and all of these fittings and connectors that you develop and prove out over the years for corrosion resistance, we also build our ground stations out of the same exact thing. So if you take your boat and your ground station, all the parts are interchangeable. There is one problem with the ground station, though, and that is most of our customers, we set up a virtual ground station on the internet, so if they just go to the internet, they can operate their boat. And so now people are starting to realize, why am I carrying a ground station around? You know, and all that extra footprint, and why do I have to set up antennas and things? And so if you go to our website, you can see some of the things, although we really only talk about the rescue stuff, but it's this super simplicity. And there's one more design thing I have to say. So for years and years, when you go out to fly UAVs in the desert, especially in the mid-2000s, the saying was one is none and two is one. So you go out with a lot of gear to be able to do missions for a period of time. And it's really hot out there, too, in the desert all the time. And but what I've noticed with one of our main design thrusts were, how do we make everything double redundant and triple redundant, so no matter what the boat operates, that it's just And it is a really different feeling when you go, it's like a car or a jet ski. So you can literally, you bring batteries, and that's all you bring. And you can go and operate all you want. And plus it's on the beach, which is pretty cool. I probably took in more time than I need to, I guess. But
And if you want, just hold the microphone and we'll close it.
oh, sorry.
Perfect.
I guess nobody heard anything. So our concept is basically design using the same size fasteners as much as you can. You can use 2 big ones. Use a few. You know, in other words, avoid multiple screws. You know, and try to get things down to one item for selection. And it's just worked really good for us. So that's all.
Okay, so to make this as valuable as possible, to get the most out of it, it's your turn. We've heard an introduction. We have some questions, but I prefer to take questions from the audience. And I think if I come down there, this cord's long enough, we can probably reach everybody.
Jeff, Phil Zalzak. A question with regard to standardization and leveraging what's already out there in the market. Would you recommend the government try to go to some kind of a common? Would you recommend that the government go to some kind of a common architecture, or just wait? Yeah, University of Maryland, right? Yeah.
It's hard to drive a common architecture from the top, because and a lot of places are already trying to do that to keep modularity. For example, Navy's doing a great job with FACE, and that's one of the best efforts of standardization that we've seen. But there are lots of existing standards that are being sort of grassroots standards that are coming out of these open source initiatives. That everyone's taking advantage of. So I think it's best to just kind of wait for it to shake out and see what happens. And you end up with a couple, like for example, right now we have Android and iOS, and well, I don't know, Palm went away, right? So, but Windows has created their Windows RT, so there's a good parallel there. So these are kind of standards that came from industry, but they didn't come out of nowhere. These are old companies that have created these standards. Except for Google, there are old companies that created these standards based on some existing standard that they improved. And so I think that probably will be a hard thing to come down from the top. You have to wait for that to come up from industry and see which one gets picked.
I'm sure we have another question out there.
I'll speak up.
Okay.
For UAVs and talking about these industrial use, agricultural use, does anyone have to say about sense of void and deconflicting with manned civilian aircraft?
Is that for me? Or do you want it?
Well, we can all answer this.
Well, deconflicting with civilian aircraft, I think is going to be, right now, especially for the industrial inspection thing, I'm trying to fly where nobody else should fly or should ever want to fly. So that, to me, has been the way I'm trying to deconflict the airspace right now. When you talk to the ag people, I think that's more of a problem, because there's a little bit more freedom in the wild Midwest of being able to fly wherever you want. And I've talked to guys that say, well, I like to fly at 50 feet off the ground, so stay out of my way. So I think as we go to the small UAS, there are some technologies that and projects that are out there. I know NASA's got one that they're working on, and there's at least 2 companies that are building kind of their deconflict the airspace projects. But I think that's going to have to come along before we really open up. So I agree with that in general. But fundamentally right now, flying for the infrastructure, if I fly, say if I was going to fly and do the roof on this building, I'm going to stay 10 feet off the top of the roof or 20 feet, and that's going to be the way we're going to deconflict. Nobody should be flying there anyway. But
And so I have a kind of a schizophrenic answer. If you're talking about what we were thinking about maybe a decade ago, about where we're going with unmanned systems, we were talking about kind of controlled systems that only a limited number of folks would have. And there are technological solutions combined with procedural solutions to help avoid problems. I mean, the DoD has been doing that. I mean, everybody and their grandmother has a unmanned system out in theater, and we managed to not kill ourselves with them pretty decently. But the problem is now, you can't pick up the paper anymore without somebody landing one on a White House lawn. They're pretty much the horse is out of the barn, and Amazon's going to be delivering a UAV to your doorstep with another UAV pretty soon. So I think that we have because to be blunt, I think that the regulators put their head in the sand, and instead of getting out in front of it, now it's the Wild Wild West, and you can't close the doors anymore. So now you've got, and of course it's not unusual for technology to be out ahead of policy. Unfortunately, this one is, I'm afraid, getting away from us. And at what point are, now I think that there are technological solutions like the software on board that will prevent them from flying, the geofencing and things like that. Of course, anything that can be put in like that can be hacked, and they can get around it. Anybody, who has any sort of application on the phone knows that that'll happen. So there has to be some sort of combination. I mean, at one time I would have said ADS-B type of solutions. Everybody should have some sort of active capability. I still see us going down a similar road to that, ADS-B being one of the various technologies, but it's not going to work for everything. The good news about these things is they all know where they're at. So if an unmanned system knows where it's at, and we can get them to start cooperating and sharing information, and the regulators can get on top of that, then maybe we can help them deconflict with one another. Now we just have to get them to not fly into crowds and things like that. And certification of operators is another thing that they're going to have to take a much better look at. Because right now, strangely enough, if you were a responsible commercial operator and you wanted to go photograph something using your UAS, you're not allowed to do it. But if you want to buy one from Amazon and fly it over to Super Bowl, there's almost nobody to stop you from doing it. So we've got the regulatory situation completely upside down from where it needs to be. And so if they can't get out in front of that, it's just going to continue to be a mess until some really bad stuff happens and somebody smart gets on top of it.
I want to say I'm glad a government official said that.
Yeah, I am not associated with the FAA.
Sure.
We can't regulate idiocy. That's one thing. But to directly answer your question, I just came out of a conference today, the Center for UAS, run by BYU, University of Colorado, and these are research projects coming out of master's PhD work. And they address this exact point where they have built a multi-stack ADS-B radar integrated onboard fusion system fit in the palm of your hand. Now, that was nice because you could put that on a small airplane and he can recognize out a certain distance, but what they realized was they made it too small. Now they've got to bring it up because you've missed a whole category of airplanes where you've got big ADS-B systems looking for small aircraft, and the aircraft are flying faster than the system can react. So the next goal is to improve the radar sensitivity so they can see this thing in depth, match it to the ADS-B data that they're getting on board. And if you get a chance to see this, and I think it's on their website, they've got 4 targets coming at them. And this one aircraft can negotiate all 4 targets at the same time at different altitudes, different speeds. And so this is the research that's coming out of our universities, coming out of the systems that manufacturers like Aurora and other guys we know are really looking forward to this, because it's going to solve the problem No, it's going to make the problem easier for FAA to address, and at some point FAA is going to say, okay, the technology's here. Now do your test and verify.
A little personal anecdote on all this. Key to me is public education. And right now, the only education the public really is getting is called the media. And we know how the media deals with subjects. And the media has a very important role. They can be helpful as well as hurtful in the way they deal with issues. But a personal example, in retirement, I got the time to finally do something I hadn't done in a long time, which was fly radio control airplanes. And I live up in Silver Spring. And, you know, these are model aircraft. Buy them from Horizon Hobby. You know, they're available to anyone, quad rotors, whatever. My biggest aircraft is a sailplane with about a 6.5-foot wingspan. Flying these in local parks. No one's ever stopped me. And then I decide one day to join the AMA, Academy of Model Aeronautics, and they start sending me all the NOTAMs from the FAA. And suddenly I realize that in Silver Spring, Montgomery County, I'm within the inner circle where even model aircraft are prohibited. And this is before the quadcopter landed in the White House lawn. So again, public education, aerospace engineer, federal employee. You know, I know that aircraft can't fly within a certain distance of the White House, but didn't have any idea the model aircraft were under that rule, let alone, you know, unmanned air systems. So, you know, to me, part of the issue here is the community, both government and commercial, needs to get together and educate the public on exactly what these systems are capable of doing. The FAA rule, when we were at University of Maryland for the Precision VTOL Delivery Symposium, the comment was that the FAA was basically taking the rule that the kinetic energy, if the unmanned aircraft didn't have the kinetic energy of anything more than a baseball hit by Bryce Harper at Nationals Park hitting a person in the stand, then that was a fine thing and wouldn't be regulated. But clearly, after incidents like quad rotor in the White House, if we don't get the public educated, then we're going to have a lot of restrictions that will be harder to remove once they're in place than getting ahead of the train, as we say here. So just a personal anecdote.
Throwing the emphasis back on technology a little bit. Putting the emphasis back on technology a little bit. Could we go down the panel one at a time and tell us the most impressive capability that you're aware of that might not be generally aware? And follow on to that is what's the next big advance that you're anticipating?
I think there's several new advances in material systems for very high strength, lightweight materials. There's a new generation of composites that are actually batteries. So imagine that your skin and fuselage structure is an actual battery instead of just incorporating antennas or wiring. I think that one's going to have it's sort of like a supercapacitor. So I think that type of technology can have a very big impact. So basically things that are in the energy density. And then the other one too, I think, you know, which a lot of us are starting to see, but everything in your cell phone is what you have in your most advanced autopilots. The resolution may not be there, but if you have a few of these things tied together, you know, you could get a lot of accuracy when you have a couple of them tied together, and that might revolutionize how where you just pop your cell phone in three cell phones and 3 airplanes, and you can do some really cool things at a very low cost. And you have a network to connect everything with.
So to me, some of the really impressive capabilities are actually, they're not necessarily capabilities, but having these capabilities at a very low cost. So, and this is sort of what's driven the hobby UAV market and the widespread uses, these MEMS, these microelectronic mechanical system sensors that allow you to measure roll, yaw, pitch, whatever, in a tiny, cheap board. So there's brand new sensors that have come out in the last couple of years. There's a $500 LiDAR sensor now that used, those are 2-3 years ago, those were $5,000 bucks, and they're smaller. There's a there's a thermal camera. There's 3 different thermal cameras that just came out that all connect to your phone for a couple $100, and they're fused with the camera from your phone. And so this is going to be on every cheap UAV in the next couple of years. And then the vision processing is also some groundbreaking stuff. I saw some amazing demo of vision processing software. There was a single camera vision system that could detect, and of course we're going to have to use ADS-B and radar and everything we've got to avoid other aircraft. But this was a single camera vision system that they had a camera in the cockpit, and it could pick an aircraft off of the horizon and tell you, which way it was going and how fast it was going and about how far away it was. And so vision processing is going to move really fast. And that will be, we're already putting that on board some of our aircraft in the lab. So I think those 3 things.
This is a hard question. They took all the good answers. I'm going to go with that. There's a paint-on antenna that I really like, and I'm going to figure out a way to use that in something. So that's probably the number one. He talked about the IR cameras that are so small. I think the sensors are just going to keep getting stupidly small, and that's going to be the cool stuff. We've been talking about I was talking earlier, we were talking about printing multi-material, and one of the cool things that my company's done is come up with a morphing actuator for small UAS. It's a piezoelectric surface, which I'm very proud of. But if we could just print that into the surface of the skin, that would be even cooler and more robust. So those are the things I could think of. But I'm going to take credit for paint on antennas.
So a couple things I'd like to probably mention. I'm not sure about how many people are aware of it, but I'm fairly impressed by the ONR AUVSI program. For those who aren't familiar with it, it's a strap-on kit that you put on a helicopter, basically, assuming that it already has some sort of autopilot system, and this thing can basically do the entire mission. It'll take off, fly a route, find a generic landing zone. It was told, just go here, kind of, and it will find a safe place to land. It'll look at the terrain, determine if there's rocks and the slope is correct, if it's too swampy, and it will come in and land on its own. I think that's really impressive technology that's going to be applied both the manned and unmanned system that's going down that line. And then similar on the other end of the scale, similar to what was discussed here, I think at the risk of being redundant, I'll repeat myself, that I think that some of these modular approaches are really going to take us a long way. I mean, the question that was asked earlier about are we going to be able to drive a common architecture, I agree with the answer that we're not at the stage that we can do that, but we can evolve towards one, and we can influence and drive towards one by providing the demand to do that. And I look at commercial activities, for instance, as one example, not to advocate for one thing, but Drone Code is one that was out in the press recently. It's a consortium of various companies coming together to say, how can we have an architecture we can share these type of things. So, it's following the similar model. It's already been established. We've already mentioned it before. In the cell phone industry, you can really lift approaches, software, and hardware from mobile technology, cell phones that we're all carrying in our pockets today, and apply it to these systems at incredibly low cost. The sensors that were already mentioned, we're really driving towards a revolution really quickly. And I think it's going to happen so fast, just like happened with smartphones, where, I don't know about you, but it just, what? All of a sudden everybody has one, and now you can't live without it. And we're going to be at that point. The warfighter is going to be there real soon. I don't see, I see that everybody is going to have their own personal autonomous air system with them in the very near future. And I think that you're going to see that same thing commercially, where that's going to be so common. So driving that price down, that's the real revolution, and that's coming up on us really fast.
What do you guys view as one of the biggest gaps in the current state of the art in terms of pushing technology for both UAVs and maybe collaborative UAVs.
His question was, what do our panel members see as the biggest gap, or actually one of the questions that I had similar was, what's the biggest S&T challenge remaining right now in terms of really going forward with unmanned systems in any of the domains?
Well, I think in the area of energy, legal lithium polymer batteries or high-performance batteries that we don't have to worry about catching on fire, that can be certified by the services to be, or by firemen or whoever's going to use these things. A lot of people are having these, these VTOL UAVs, and they all have very high-end batteries, and sometimes they like to buy the cheapest battery, and sometimes those batteries catch on fire. So I think that's a problem area, and then also converting over to heavy fuel for safety purposes, so you don't have gasoline flying around, and you have it's a bit different with a UAV than your lawnmower in the garage, but even garages burn down a lot, because of the gasoline weed whacker or the gasoline lawnmower. So I won't say any more, so I don't think anybody else has.
I think modularity is a big one, and just the use of systems engineering in some of these small systems, because a lot of them are kind of built more like prototypes, and when they needed to do something else, they have to build a different one. But also there might be technical solutions to the regulatory issues, and that could be a great area of research. I know a lot of people are already working on that in the RTCA SC228, and some of our test site guys are familiar with that. But so there might be a technical solution that could come out of some of the research. I think MIT Lincoln Labs is working on some of that stuff to just like the radar ADS-B stack that he mentioned. But it can't, it's either too small or the big one is too heavy for the SUAS, and so that's I feel like that's a big gap. But definitely batteries too and power.
I'm going to help you. I think the biggest gap is communications, lightweight communications, and then the trade-off between communications and autonomy. Because the more you put onto the aircraft, the less you need to communicate command and control. But right now the options for commanding small UAS in a secure fashion are really limited, and I think that's the one area that I would like. If somebody has one, talk to me afterwards, because we have a project with the Department of Interior, and we can't actually get to where they want to be because they've got requirements on the radio, and there's no radio that fits that requirement. So to me, that's what I'm shooting for.
So my answer is going to be a little less on the technology end. Obviously, there are lots of challenges, and more on the process end. We have got to come up with better approaches to rapidly certify for safety and security systems. And I think that is true for both DoD and for commercial systems. And an approach to do that in a logical fashion, but from a cost perspective, it was mentioned earlier about the cost of certifying these things. I live that every day. Everybody I work with lives it every day. Sometimes we spend more money to certify a system than it costs to develop the system itself. So to be able to do that rapidly and for a lower cost, and there's technology involved in that, but there's also a process involved in that.
Let me go back 1 second here. I did not pay Steve to talk about one of my favorite programs, which was AUVSI. But if you want to know more about AUVSI, because it is kind of a prized child for me in terms of what it can do, what it's demonstrated, and how it will play out in the future in a lot of unmanned systems. But if you go to the ONR website and you go into the departments, science and technology departments, under Code 35, there's a brochure there you can download, which goes through a lot of the air warfare, autonomy programs, as well as the other programs we had in there. But AUVSI is in there and goes through a lot more detail if you want to learn more about it. But AUVSI is a good example where, again, the end user is a Marine on the ground, 5 minutes of training with an iPad, smartphone, basically tells an unmanned VTOL system where it wants to land, It has the sensors on board to discriminate obstacles that the Marine on the ground doesn't see, be able to choose a path to a clear area, request permission from the Marine on the ground for an alternate landing site, and then proceed. And the funny thing was, the first demonstration they did at Quantico was unintentionally performed right after a snowstorm. So there was snow on the ground, and the rotor wash kicked up a nice whiteout condition, and the system still effectively landed without any problems. So a lot more to come, but miniaturization, modularity, I agree with everything the panel is saying. It's important that these, in terms of numbers of systems, for the price to come down, and the more they're modular, the more they're integratable into other platforms, the more success we'll see and the more utilization. So definitely agree with what the panels have said here. And in terms of the batteries, again, if you go on YouTube, you can see what happens to a lithium polymer battery that's been mistreated. It's not a pretty sight, and like you say, they clearly are the way of the future, but there's still a need for safe use and education of the user. And one last comment on to Tony's power and energy. If you didn't see in today's kind of web services, Elon Musk and Tesla is about to, I guess, unwrap to the public a new electrical power source for home use that theoretically can power a home for a week. Something more than the Nissan Leaf plugging that into your house when you've lost, utility power. So I'd be curious to see what Tesla has up their sleeve, but knowing what they've produced before, I'm interested. And on that note, another example of where there's cutting-edge opportunities coming that will apply to unmanned systems, the X Prize Foundation, and if you've paid attention to some of the things that they're investing in, of course, space was their first big one, but they have a number of competitions going on, one of them right now, which is basically bringing the ability for every user sitting out here in the audience at home to be able to do medical diagnostics on themselves with miniaturized health devices. And there's a lot of application here, obviously worldwide. But again, this is relying on miniaturization, small sensors, things that we're finding in iPads and iPhones and hopefully Apple Watches that can monitor blood pressure in the future. So a lot of things across commercial space in terms of applications that can come back and feed either into unmanned systems, or likewise unmanned systems feed into other practical applications, whether it be the medical industry or agriculture or emergency rescue services. It's a big world with a lot of opportunity. So I think on that note, are we ready to move on, Ben, or do you want to take, okay, we have time for one or two more questions from the audience. Matt?
Well, so far we've been talking about the technologies in unmanned systems and how they apply to the future of unmanned systems. When we talk to a lot of companies, especially the FedExes, UPS, other folks like that are doing manned aviation now, in the near term, they're not interested so much in the unmanned systems as the effect of that technology on their current manned aircraft operations. So kind of segueing off what you just said about the technology transfer, I was wondering if you could each address what you see as the biggest impact on manned aviation, besides kicking people out of cockpits, that the UAS and the technology presents.
So I think the best model that you can look at is what's happening in the automobile industry. So everybody's focused on the Google car. It's really cool, and I can't wait to buy one. And I really can't wait to give my son one, so you're all safe on the road. That being said, the Google car is not going to be here tomorrow. But what is here today is the technologies that are being built up towards the Google car, exactly like Matt was asking. What we're going to see, like I mentioned with the AUVSI, so I was at the demonstration in the snow, freezing my butt off, and it was great. And there was a bunch of general officers there from the Marines and the Army, and a lot of them had a helicopter background. They could care less about the unmanned aspect of it. What they said is, wow, that could really help out my pilots, because just as was mentioned, you got that whiteout condition, and that system didn't care whatsoever. You know, very similarly, as soon as people started seeing the X-47 land on the carrier, people started scratching their heads and saying, so why are we having pilots in the loop? And most of you know that most of the time the pilot is actually not in the loop, even in your commercial airliner. So as these technologies start feeding themselves in, they're bringing particularly the autonomous capabilities that can offload the pilot, make them more mission managers. I think that there's going to be a long time before we're going to be pulling pilots out of cockpits, particularly for passenger aircraft. But these technologies that we're going to see in unmanned systems will be pervasive just as much in manned systems, because they'll be there to augment and help out the pilot and continue to raise the level of safety. In fact, in general aviation, I think that there's a lot of real potential there because these things are getting so small and so cheap. You know, as a private pilot myself, I would love to be able to leverage some of these technologies that we're developing for unmanned systems.
The pilot, take the pilot away, but I think the things that the sensing and technology that are being developed are going to go toward a lot of the aircraft health and monitoring that. That to me will be the area where the things that we're developing in unmanned systems, because you've got to know how much battery level you've got to know whether something's vibrating wrong, you got to know. I think those are going to be the things that are going to come back and make aviation more safe.
One of the big connections with unmanned and manned aviation, I think, is the BAA that came out for the DARPA Alias project, which was a request by DARPA to basically build R2-D2 that you could put in any airplane, and it could help the pilot. Because FedEx, for example, has, you know, some of these aircraft are going across the world with a crew of 5 because they have crew rest issues. And so if you could have, you know, a semi-automated aircraft, then the crew could go to sleep and the aircraft could wake them up when they had a problem, or when it was time to land, or when they had some weather or some malfunction. So I think that's one avenue. And also I think there's going to be a lot of, especially with the larger UAS, where they're very critical, and a lot of human factors engineering is going into it. I think we're going to learn a lot about human factors, and you know, we want to see this automation put to work in large aircraft and rotorcraft, so that they can land in zero visibility, and they don't have, you know, it'll be safer. But at the same time, we're going to learn more about the out-of-the-loop performance problem, which is a problem where when you automate the system, when everybody has a self-driving car, we're going to forget how to drive. So when you have to drive the car, which is going to be once in a while, it's not going to be natural instinct. So you get something that happened like Air France 447, where the pilots, they're young pilots, they grew up flying automated aircraft, and then they, you know, the autopilot went into a different rule, and they didn't know how to fly the airplane. So I think that's going to be one factor, and we'll learn more about that because we'll be using these automated UAS, and we'll learn more about how to deal with those human factors.
Yeah, I think, like in the U.S., we're all used to when you have bad weather conditions and stuff. It's pretty easy to for our pilots to change course of aircraft and land somewhere else safely. And I think where recently it seems like we've been having some real problems is on these transoceanic flights, especially out in Asia, where it's a really big deal if you go off course. There's not a lot of options where you can land, and so you try to fly through that storm or above that storm. And I think I would rather see more automation on keeping the airplane from having a flight failure mode, a stalling mode. And then the other thing, and I think this should, I would feel more comfortable if pilots were more mission managers than worrying about all the decisions, I think. The other area that my friends in the air traffic controller world tell me is they would really like to see a lot more happen in automating what's going on in the traffic control. People are very stressed there. You know, that's a, it seems to me that's an area that we could avoid a lot of near misses, a lot of problems. And so I would like to, you know, I would like to see more of what's happening in the aircraft and the platforms happen in the ground control station.
Steve or anyone else who wants to address it. I'd like to hear more about autonomy. We heard about ONR's AUKUS, but I was wondering, where's NavAir going with autonomy? What is needed? What's working? What's not working? If you could address those kinds of things, I'd appreciate it.
Yeah, considering that's what my job is supposed to be, I probably should have talked more about that to start with. We've done a really good job in some very focused areas in autonomy, launch and recovery being the one that stands out. You know, we've been able to launch and we routinely launch and recover a helicopter from a ship, you know, with the Fire Scout program. So we've shown that we can bring fairly sophisticated autonomy to bear. The X-47 is another example. The Scan Eagle, what we're doing with the Blackjack program. So we've done a really good job there. But when we start talking about mission type of autonomy, we've done a pretty terrible job. So I'll use the Air Force as an example and pick on them because it's more fun. The Air Force, you know, they do what they call orbit, so they keep in 24/7, surveillance over an area. They look to do like 50 of these orbits simultaneously and keep them in the air. Today, one of their primary sensors is a simple, so to speak, EOIR sensor, and they have an operator basically staring at the screen, you know, looking at what they're looking for, and they're adding new payloads. One of them, for instance, called Gorgon Stare, which can look in multiple locations at one time. And so I saw some math one time done by the Air Force that said that if they meet their goal of flying the number of orbits that they want to fly, and they get Gorgon Stare on all the aircraft they want to get them on, and they use their current technique of analyzing the data. So just to analyze the data, it would take enough people that's half the size of the U.S. Marine Corps just to look at the data that's coming off of the system, not to fly the systems or anything else, just to look at the data. That's probably unsustainable. So I think that the direction that we need to be going in is twofold in the area of autonomy for the Navy. First of all, reduce the manning requirements. You know, some people say that the number one problem with unmanned systems is the number of men it takes to operate them. And the reason for that is not necessarily inherent in the vehicles. It's because they can produce so much more data. The sensors are getting more sophisticated. Their endurance is so high. There's so many of them when everybody can carry one themselves that we need those type of mission type of autonomy to be able to look at the data and also to be able to share data among various systems in a more sophisticated way for that mission element. And the other one is autonomy for the inevitable loss of communications. Anybody who's been involved in unmanned systems knows that the link is the most unreliable thing that we have. So we have to be able to have autonomy that will be able to allow us to continue safely with the missions while we have degraded communications. I'll point out the DARPA code program at this point, which I think is taking us down some of that direction where they want different air systems to be able to work together in a cooperative manner, but in a denied environment, denied communications and also denied GPS, because those are two of the Achilles heels of our unmanned systems. So I think that we need to start and there's technologies that exist in those directions, but our ability and our investments in being able to field them, lots of great research, very little work being done to transition some of those mission-level technologies and some of those autonomous elements that allow us to break that tether more frequently of that data link are probably two places that we really need to be investing today. And then we'll be able to get to some of the really advanced behaviors in the future, like swarming and things that people like to talk about.
I think at this time we probably will call it a wrap in terms of the panel. I want to personally thank all of you. You've done an excellent job. I think we've kept the questions and answers flowing back and forth quite well. and hopefully the audience has at least a bit of an itch scratched in terms of our issue this evening. I personally want to thank you all for coming out this evening, considering the weather and other options that are out there, I'm sure. And at this point, turn it over to Ben Solomon, and then after that, Phil Zelsak will come up and give a few words.
Yeah, big round of applause for our panel and for our moderator, Mike. So I think as everyone's seen here, we sort of fulfilled one of the two missions of SMIT, Southern Maryland Innovation and Technology Group tonight, which is to highlight disruptive technologies. And I think our speakers definitely did that in the area of autonomy and unmanned systems. I want to also give a quick shout out, Robin Finicom from St. Mary's County, big supporter of SMIT, and Ron Casey from Maryland TEDCO. Ron, if you could raise your hand. Thanks for the help tonight. So the other mission of SMIT, as I think most of you know, is venture creation. And what we're going to be doing in the next 2 months, to give a little preview, next 3 months, is shifting over. So we've had our last two meetups. Last month was on 3D printing. This month was on unmanned systems. Those were sort of the disruptive technology silo. We're going to shift over to venture creation in a big way. So next month will be a session on ideation. So let me get a quick show of hands. Who here has a business idea, a product idea, a concept? Anyone have anything that they want to nobody yet? Okay, yeah. It could be anything. Anyone here want to have a product idea? Okay, I do too. So our next session is going to be on ideation. How do you actually? You're going to hear from people like entrepreneurs, on this panel. How did they come up with the ideas that they talked about tonight? What were the methods? How do you go and scan the market for an opportunity? So we're going to have a session on that in March. In April, we're going to have a session on how do you take those ideas and actually turn them into a business model? How do you go out and interview customers to validate your hypothesis? Some of this is going to borrow from the methodology that we teach in DC I-Corps, which I'm an adjunct for. DC I-Corps is a NSF-sponsored technology venture creation organization. So we're going to borrow from that. And then in May, we're going to have the first annual Crab Pot pitch contest, which is a unique. I had slides that showed all this, but I'm going to create it visually. So Crab Pot taking place on Thursday, May 21st, in this building, in this room, is going to be a pitch contest where we'll have 4 to 8 pitches coming from you in the audience, and a panel of judges giving feedback. We will have some prizes for the winners. So also borrowing again from the DC I-Corps methodology, it's not going to be a single pitch. We're not going to evaluate you on that one pitch. We're going to evaluate you on the extent to which you iterate over a period of time. So we're going to ask people to actually submit their concepts in the course of the next 3 months. And we'll post all this information on the meetup site, but also if you want to participate, we just developed a Google enter crabpot@gmail.com. So if you're interested in being a pitch at Crabpot, email that, or also go to our meetup site for more information. We're going to now move over to community shout-outs. So Rick Tarr from NOC AD is going to lead those.
Sure. So one of the things that we'd established early on with our meetup was doing shout-outs for the community. So these are, in cases of your first time here, these are small tweet-like size shout-outs, and it can be about various things, about the community, about events that are happening, and that sort of thing. So to kick that off, I think Phil Zelsak has one about Greenwell.
Okay, thank you, Rick. I'm going to give you about 2 or 3 minutes on what the Greenwell Foundation is, but just for fun, does anybody know, has anyone ever been to the Greenwell State Park? Just raise your hand. All right, you know how it got started? Anybody? Well, you know how it got started is a guy had a concept in 1966. His name was Philip Greenwell, had a farm. He didn't quite have 600 acres on the Patuxent River, but he established a foundation, and he started talking to the state of Maryland. He said, I had this concept. And the concept is, wouldn't it be cool if I had a place where people with and without disabilities could come and just enjoy nature in an inclusive environment? In other words, you wouldn't want to make it all disabled people. You want to mix it up so people learn from one another. All right, so he cuts a deal with the state of Maryland in 1971. And that was 1966 and 1971, if you guys followed that. And so in the 90s, they opened up the park to the public. And in 1997, they opened up their first activity, which was therapeutic riding. You might be familiar with that. And in 2005, they started camp programs. So what's the mission of the Greenwell Foundation, as conceived by this guy named Phil Greenwell? That was to provide programs for people with and without disabilities. So what do, right? Well, they have specialized camps. They've retained the therapeutic riding, and they have veterans programs. So why am I standing here? Well, last summer we had up to 503 enrollees in the camps. But what we like to do is to increase categories in 4 different areas. One is children with disabilities, children in economic need, children of veterans, and then another category by themselves, veterans with disabilities. All right, so how would we do that? Well, it's kind of like, I don't know if you're familiar with the Christian Children's Fund or what they call the Child Fund now. You actually fund a kid. In other words, for as little as $200, you could send a disabled child to a camp for a week, or, you know, for $420 for 12 weeks for a riding camp. Anyway, if you don't have one of these flyers, steal it off a seat that's got one. So what do I want you to do with it? I want you to take this flyer, and if you're in a company, you have somebody who's designated to worry about community support. Hand it to them and say, hey, this sounds like something good that's good for Southern Maryland, good for our community and the people in it. Now I'd like Caitlin Fernald to stand up. All right, who's Caitlin Fernald? She's lead for development at Greenwell, and her telephone number and her email address are on the back of this. So that's really the end of my dog and pony. Steal one of these flyers if it's not on your chair, and go do some good work for the community. Thank you for your time.
Yeah, a really long tweet. So does anyone else have any shout-outs? Yeah, Robin, sure. Really long quote here.
Business and Economic Development will be exhibiting at the Paris Air Show again, and each time they go, they invite companies to go along with them. We'll be posting the flyer about how you might apply to be considered and what the obligations would be, and I'm sure there's some cost involved. Through the SMIT website, we'll put it out to all the members, so keep a lookout for that, because that event's coming up fairly soon. The other thing is, I really don't want to end the evening before we find out if the University of Maryland Humanoids can cater our next meetup.
Any other meetup or any other shout-outs?
Sure, I'll give a plug again. Just as a reminder, I have flyers and sponsorship up here. The student competition is being held in June. We have 55 teams that have registered from around the country. I think about 50% are domestic, the rest are international. We're going to try to have a interview day, the day they check in, which happens here on, I believe it's June 17th. So grab the flyers and look on the SMIT website before you leave. Thank you.
And for the first time, a University of Maryland team will be competing, right? Yeah.
I'd like to let you know that TEDCO has a relatively new funding program for cybersecurity startup companies that could make good use of $100,000. It's on our website, or you can have them talk to me. Thank you.
Thanks.
Just want to let everybody know that Packspace is officially moving into their new space, I believe, end of March. So we set a date for our next open house of April 12th. Keep an eye on www.packspace.org for more
And for those of you that don't know, that is our local makerspace, hack space, St. Mary's County. Sure.
Wasn't aware they did this, but I just want to give a shout out. Does anybody know what the WARM program is here? There are a lot of churches. We're in the middle of it now. A lot of churches that are still going on. They're in desperate need of monitors and people to donate food for these programs. Now, I know up in Leonardtown, St. Paul's United Methodist has it next week. Please go onto the website and see if you can find out about WARM. If you have time to volunteer, please do. Thanks. South Point Church is also doing it.
Yep. Yeah.
Check the notes.
May 9th at Greenwell State Park. The group. There you go.
Host third graders, I think from Carver Elementary School, who have won a robotics competition to come to a future meetup to show their stuff. So you'll get the notice about that. It'll be a lot of fun, third graders, and they'll be the future for us. So we'll have fun with that.
University System of Maryland wants to build a third building on the Higher Education Center campus. Governor's budget delays for 2 years, takes it out of the category of making progress. You want something like that down here, if you want an investment from the University System of Maryland for the first time ever, governor's staff needs to hear from you. Our delegation is behind it, but they're all new. They can't get it done. Governor's staff needs to hear from you right now. Make it happen.
Anybody else? Okay, thank you.
Great, thanks everyone. So we're going to wrap now. We can stay in this room for another about 20 minutes, and then we're also going to have an after event at the Tides right down the street. So encourage you to, to stay there, go there. I'd like to give a big thanks again to our panelists. And we will see everyone here hopefully next month, March 19th, for a session on venture ideation. So thanks again for coming, and good night.